Hey guys, so today's video, I'm actually coming as sort of a follow-up video to one that I posted a while back, and I had posted it was a piece of development equipment for the Nintendo 64 that was used by developers, and that's called the Intelligent Systems Viewer64. So as you can see it here, it's quite the sweet little unit. It's got a SCSI interface on the top, which allows high-speed transfer, or high speed at the time during the 90s. So in today's video, I'm actually going to be showing you guys an advanced feature that this particular development cartridge has, and that is a debug print function. And that allows developers to see particular messages at particular moments during game execution or during gameplay, and also allows them to print specific register contents or register data, and allowing them to sort of have feedback of what's going on during game execution. So I'm going to show that to you guys and get your feedback on that. So let's check it out. So one thing I want to mention about this particular development cartridge, and that is that it requires a specially modified N64 console in order to operate properly. There are a number of tie lines that have to be connected from specific points on the cartridge edge connector inside the N64 console to different areas on the main PCB. This is to bridge a reset signal and also a debug interrupt line. This allows the cartridge and the N64 to communicate properly with the development PC, which is receiving debug messages. Without the specially modified console, the cartridge would not be able to print debug messages onto the development PC. This allows the developers to see what's happening in real time while the game is running on the console. So essentially how this development cartridge works, if you're using it for homebrew purposes and your own development projects, there's a specific debug address that has to be encoded within the ROM once it's compiled. And this debug address, so to speak, is actually dictating a specific location in the RAM memory where a buffer is put in place to hold messages that you want to send out to the development PC that's running a specific program and is monitoring that memory address for messages. So this is essentially a debug address. It's just an address for a buffer location in the SRAM of the development cartridge, and the runtime program has to be aware of that specific address in order to monitor those messages that you want to send out. So within your source code, you place different print messages within the code, and when those areas of the program are reached, they will send out a message to that buffer, and the runtime program is constantly running and watching that, waiting for these messages to occur, and then copies them and prints them out onto the runtime session, the runtime program, which is essentially that little MS-DOS window that's running on the development PC. And so it relays all those messages that are being sent there to that specific memory space within the SRAM. So it's pretty interesting and pretty useful for debugging purposes. It's not a full-blown source code debugger like the partner N64 and the SN Systems development cartridges. Those are true source code debuggers, which actually in real time will show you which line of code within your source is causing problems or is the area or the purpose of a crash. It's still a very useful development tool, and it also allows you to preview and view textures and samples for previewing. Now, one thing I also wanted to mention is that this debug print function is also fully supported by the 64 drive development cartridge. Marshall, he implemented this exact feature into his source code and to his firmware. And so there's essentially the same level of debugging functionality if you get yourself a 64 drive for doing your own homebrew. And using the USB cable, you're able to perform this exact same function. And there's actually a couple of sample ROMs there. The source code is available on the retroactive website. However, I also posted a number of sample source code files for you to play with, and those are available online, and I can attach them into the description of this video if you wanted to check those out. But it's pretty fantastic that the 64 drive essentially does support the exact same feature as the Intelligent Systems Viewer 64, so that's pretty cool. So I actually have a really cool surprise for you guys here today. Now, I know probably a lot of you have heard of the N64 Zelda Debug Builds that had been put into the wild some time ago. The cool thing about these builds is that there were leftover debug messages by developers during the development of the Zelda games. I had been contacted by a couple of people in the past about possibly using my development cartridge to potentially load those builds and view the messages on the output. And so I thought, yeah, that's kind of a cool idea. I should definitely try and get into that. And so I'm going to show these, both Majora's Mask and Ocarina of Time, loading here, and I'm being played on screen, and then you'll be able to see the debug data being loaded onto the development PC runtime program. So now something that I just want to talk about, there was a problem that I ran into with development card. So the issue here was that my Intelligent Systems Viewer 64 was a version 1, so it was one of the earlier models that had come out. And there was a maximum memory capacity of 32 megabytes. Now, later on, there were different models that had come out with larger memory capacity, and so developers had used and upgraded their units to the 64 or the larger memory capacities. And so these debug ROMs were 64 megabytes in size. And so when I had them initially, it's like, well, I guess I can't use them because my unit only accepts up to 32 megabytes of ROM size. And so I'd talked to different people online. They said, oh, you can just compress them down. There's ways of doing that. And, so I started looking around, and there were tools around, and I tried that, and nothing was working. I had a lot of problems with it. And so finally I got some help from my buddy Jace. He had contacted me through Twitter and had talked about different things and that he was working with. And I sort of thought, hey, this is the type of guy that would probably know how to do this. And so I approached Jace and mentioned this problem that I had and how I needed to compress them down, but there was also some debugging addresses that had to be specific and in a specific location in order for the hardware to work. And so Jace took a look at it, and Jace was able to help me with that, and he managed to go in and manipulate everything, compress it down, but also go in and essentially ROM hack the ROMs in order to allow that specific debug address that the Intelligent Systems Viewer 64 requires in order for this feature to function and allow debug messages to be sent through to the console. And Jace was able to help me with that, so it's pretty awesome. Okay, so I'm going to load Majora's Mask, and we'll check that out. So as you can see, the ROM is being loaded into SRAM on the development cartridge. There we go. So you'll have to forgive me using my camera to record the monitors. However, it's a little difficult to get the capturing device rigged up on my Windows 2000 PC, so bear with me. This is a rough capturing method, but it does justice just to give you a perspective on how the debug messages come up. So the game will crash once I start loading it here, so we'll just go through it here. So once I actually enter in I'll enter my name in here. And we'll run the game. and then it should just crash. Now you'll see the debug messages start to trigger. And there we go. Now you can see how it's in unison with the debug runtime program that's running on the development PC. Now, there are a couple of modes where the controls, it'll actually run in an automated way. If you can hit the left trigger and it'll actually run in a sort of repetitive, just sort of a cycling mode where it cycles through all of the different screens for stack memory, addresses, and register data. Or you can actually trigger it manually. So if I hit the L button again, and then I can just use the different A and B buttons and trigger them manually. And now you'll see how it didn't print to the debug console. So if I hit up on the directional pad, that triggers the sending to allow the signals, the debug messages, to go through to the debug console on the runtime program. So we hit it now, you can actually see them all being forwarded to the runtime program, which is pretty cool. So I'll just keep cycling through. Now people have managed to get these specific crash screens, these debug menus, to come up and have posted them, but now with Majora's Mask, it relays the messages to both the video output and also to the runtime program running on the dev PC. And so there's different, you can see here there's different register information and variables that are being displayed. Just keep cycling through them here, it's pretty cool. And then eventually it will restart. CPU test. And then we get essentially a memory dump. It just keeps cycling through different areas there. It fills up that debug runtime program screen there quite a bit. And then we get the congratulations, all pages are displayed, thank you, you are a great debugger. And that's pretty much the end of the process, and then it repeats and it goes into different crash screens. So that's essentially Majora's Mask debug ROM. That's how that one works. So now with Ocarina of Time, it's a little different. So let's check that one out. Okay, so I just loaded the batch file here that I have for the second ROM, the Zelda ROM. So this is Ocarina of Time Debug ROM. And this one's a little different. It actually allows the game to be played in real time while displaying debug messages on the dev PC side while the game is actually running. So the game doesn't crash. So I don't think this has actually been done before, so it's pretty cool, and really I hope you guys get a kick out of this. So it's pretty awesome. So here I go, I'm running it now. So loading into the SRAM memory of the development cartridge, 32 megabytes. And again, thanks Jace for all your help getting these ROMs ready. And there we go. You can see how it's a little bit more involved there. And there's a lot more debug information that's flying by on the screen as the game is played. And I'll just let you guys sort of check it out. You can see how there's different alpha, probably different texture information and registers and whatnot being displayed. And this is to assist the developers in making sure that the game is running properly. And so you can see how it displays different information as different events are occurring. Well, yeah, pretty neat. And so now if I select any particular ROM, this is just for test, I'm not really going to be playing this much. And so if I just start running around here, you can see how the debug messages will, and there when I die, there you go, and I see how it's like reloading the level, and so you get specific processes that occur for that to happen. There it is again. So if I go in and select different areas here, now you can actually hear that. I don't know if you guys heard that. There was actually a PC speaker beep. So that was a communication that occurred with the development cartridge, and over the SCSI port, it caused the PC, my development PC, to have a PC speaker to actually create a tone there when the new level loaded. So that's pretty interesting. I'll try something else out here, just randomly grabbing one. There's the beep again. Try talking to this guy here. As you can see, follows it in sequence. Now if I hit start, so now if I just hit start button right now, you'll actually see how, as I select different items, it actually registers on the debug screen. And if I change menus, now here, this is kind of interesting. There is actually a loop occurring there, and so when I'm selecting different items, go back to there. So if I move the selector around, you'll actually see how the information in the loop changes. So the number on the end is changing from 80 to 77, and it's down to, I think, 71, right? Anyway, it's just a kind of a neat little thing that's going on there. I'm sure all of you are probably like, oh my god, this guy can't play. So different events occur. So as you can see, you get the point of it. It's pretty interesting to see how it all works, and how there's probably just endless number of debug messages on these ROMs that are in place, and so it'll be pretty neat to be able to play with that and check them out. Anyhow, I just wanted to show that to you guys. I thought it was pretty cool and interesting to see, and anyhow, I hope you guys enjoyed that. So I just want to take a moment here, guys, I want to give a big shout out to Jace. He helped me quite a bit with the compression of the debug ROMs down to 50% down. So we had to compress those down to about 32 megabytes to fit into my Intelligent Systems Viewer 64, and in order to allow the debug messages to present themselves. So we owe that to Jace for doing that for us. And so Jace, thanks so much for doing that. Really appreciate your help. And Jace had to go in and manipulate the debug address in order for it to function correctly. So there was lots of essentially ROM hacking that he had to go in there and manipulate all that hex code in order for it to load properly with my unit. So that was pretty awesome. We were testing back and forth. It was really cool. Lots of fun. So Jace, thanks a lot. Appreciate it. So everyone, I hope you guys enjoyed the video. If you haven't subscribed, please do so. And thanks so much, guys. Hope you guys enjoyed and had some fun. We'll see you guys later. Ciao.